All right, come back. So let's quick talk about this. Skew lines are coplanar. Is that sometimes, always, or never true? That is never true. Okay, we define skew lines as non-coplanar lines that will never intersect. So when I'm looking here at this line here, any line that is parallel to that line, I can draw a plane through. For example, here and here and here. Those are all lines that are parallel to the green line. Any line that intersects it in this diagram is going to be perpendicular. So all these blue lines are perpendicular. Any line that I haven't yet covered, that's going to be skew to our original line. And here is our original line. So when I talk about this line here, it's never going to intersect. It's not in the same plane. And I cannot describe it as parallel or perpendicular. Your baskets in front of you can act as this same cue. With your group mates, would you please choose a highlighter or a colored pencil to represent one of the sides and place it on one of the sides on one of the lines of the basket, and take a minute and have your group talk about which lines are parallel, which lines are perpendicular, and which lines are skew. And the market says top. Go. All right, come back. Come back. Intersecting coplanar lines are perpendicular. Sometimes, always, or never true. Intersecting coplanar lines are perpendicular. Sometimes, always, or never true. So always true in this figure that's a cue, but what if I had this line here intersecting this line? Does it have to be perpendicular? In order for it to be perpendicular, what does it have to measure? 90 degrees. 90 degrees. Does everything measure 90 degrees? So we're going to call this sometimes true. That's going to be sometimes true. Hey, parallel planes intersect. Sometimes, always, never. Go. Never. Parallel planes are never going to intersect. With your basket, everybody think about the top, if there was a lid, and the bottom of the basket. Those are parallel planes. Would they ever intersect? No. They would never intersect. What's interesting is the sides of the basket. Who's talking on it? Is that one? The sides of the basket are actually tilted. So the baskets actually, if you look at them, do you see how these are like actually trapezoids here on the sides? So those planes eventually would intersect, would they? Our only parallel planes are going to be that lid and the bottom. All right, parallel lines are non-coplanar. Sometimes, always, never. Go. Never. Because parallel lines, if they're parallel, they're in the same plane. So that's why that's never true. Intersecting lines are coplanar. If they intersect, they are always in the same plane. The only way that lines can intersect is if they are in the same plane. Somebody last class said, well, we hadn't had them always, so I just guessed always because I figured you would have to include at least one always. That's not bad. Is that inductive or deductive reasoning? Is that a pattern she's looking for? Inductive. Hey, we wanted you to write the converse and determine the truth value. So the converse is where you take your conclusion and your hypothesis and switch them. So instead of saying if lines are perpendicular, they intersect at a right angle, we swap it around and saying if lines intersect at a right angle, they are perpendicular. Would you say that is a true statement? Yes, sir. And that definition of perpendicular runs both ways. If lines intersect at a right angle, then they're perpendicular. If lines intersect that are intersecting lines are perpendicular, they intersect at a right angle. So that works both ways. So this one's good. If two angles are vertical angles, then they are congruent. Let's switch it around. If two angles are congruent, then they're vertical. Is that always true? No, Dixon says no, it's not always true. I can have congruent angles that are not vertical, so this is not a biconditional conversation. That converse does not say the truth. If two angles are same side interior angles, then they are supplementary. So let's switch it around. If two angles are supplementary, then they're same side interior angles. Is that always true? So here's the thing. I even have a hard time with this one. I don't even think that this one is always true. You ready? Same side interior angles, but that's assuming that my lines are parallel. So if I have a transversal and I have same side interior angles, they're not guaranteed to be supplementary unless I'm told that the lines are parallel. So if I'm not told the lines are parallel, I can't guarantee that same side interior angles are going to be supplementary. When I switch the converse around, yeah, that's not true either. Because I can have a whole lot of supplementary angles. Case in point, any linear pair is supplementary, and that has nothing to do with same side interior angles. So number 8, we don't even like anyway. Turn paper over. When we have a parallel line system that looks like this, I want you to pay attention to something. If I have two parallel lines and a transversal that intersects both of them, it creates a line system where everything is either acute or obtuse. In easy terms, it's either a fat or a skinny. Because if I'm told that these lines are parallel, and these little triangles here guarantee that's true, once somebody tells me that angle 6 is 53 degrees, then I know that every other skinny angle is also, did I say 56? Is also 53 degrees. Angle 6 is 53 degrees. Hey, this is vertical 53 degrees. This is an alternating interior angle, 53 degrees. This is a corresponding angle to this one and a vertical angle to that one, 53 degrees. Every single one of those green angles is what? 53 degrees, because those lines are parallel. So the first rules we talked about was if the lines are parallel, then these cool relationships are true. Vertical angles, corresponding angles, alternate interior and exterior angles are always going to be congruent. If I want to figure out the supplement or the linear pair, I'm going to do that mental math we talked about last time. 53 degrees, count up to 180. 53 plus 7 is 60. 60 plus 120 is 180. So that means the measure of this angle is 127. Do you understand how I did that math by counting up? You could also type in your calculator 180 minus 53. I like to use my brain. So that means that every other fat angle, every other obtuse angle is going to have that same measure. The first one, because it's vertical. Then I have alternating interior angles. I have alternating exterior angles. So I can see all those relationships. So when it's asking me all of these angle measures, everything in that parallel line system is either going to be a skinny or a fat. It's either going to be acute or obtuse. It's either going to be 53 or 127. Does that make sense to you? All right. Number 12, we want to solve for x and y. Turn to your partners and say, what equations are you going to write? On your marker set goes. All right, do we agree? 2x is equal to 34, x is equal to 17. Over here, add 35 to each side, subtract 2y from each side. That was a 1 step. Are we all okay? All right, we need to make sure we're good with that algebra. All right, decide whether BA is parallel to DE. This is where we start talking about the converse. If you're told the angles are, if you're told that the lines are parallel through either it being given to you in the diagram or somebody says the lines are parallel, then you can count on these angle relationships. If you're told the lines are parallel, these alternating exterior angles are congruent. If you're told the lines are parallel, these corresponding angles are congruent. If you don't know if the lines are parallel, you're in a converse situation. You can prove they're parallel if these things are true. So when we're looking at, hey, wait a minute, are the lines parallel? Here's AB, here's DE. My hint for you is to take your pencil on a piece of paper and extend the lines and make them longer. It makes it easier to see, which is the transversal. Because as soon as I look here, I can see that this line here is the transversal, and I'm looking at 135 degrees and 45 degrees. They look like supplementary consecutive interior angles to me. That's a lot of vocabulary words. Supplementary, 180 degrees, consecutive next to each other, or same side, interior angles. If I have consecutive interior angles that are supplementary, adding to 180 degrees, I've got my lines are parallel by the converse. So yes, these ones are parallel because of supplementary consecutive interior angles that converse. Make sure you include the word converse. The consecutive interior angle converse. All right, coming over here. Here I have BA and DE, and here I have my transversal. I've got 105 degrees here, angle addition postulate. If I add them together, I've got 105 degrees. So are the lines parallel? Yes, because I have congruent, alternate, exterior angles, which tells me that I can use my alternate exterior angles converse. Libella says if I'm proving the lines are parallel, I need to use the converse. If I'm given the lines are parallel, then I don't use the converse. It's just the regular rule. However, it is for you to keep that straight. All right. Let's quickly go back to the beginning of the unit. Take out your binders so that we can talk about things. Because when you have your binders open and you're turning pages and you're looking at your diagrams and your pictures and the notes, that's how you get smarter. That's how you review for a quiz. Are you ready? We started off with these conversations about parallel, perpendicular, skew. We talked about angle relationships, vertical and supplementary. We practiced more parallel planes perpendicular lines, and skew lines. And we played with our new angle relationships corresponding alternate interior, same side interior, and alternate exterior. We learned all kinds of new vocabulary words. Parallel, perpendicular, skew, transversal were all to you from Unit 1, but these were our new ones. Understanding all these angle relationships, and I had a transversal. We did some practice with them, especially when the lines were not parallel. And we played with using different versions of the transversals for different intersecting lines. Notice 3.1b is where we said, hey, wait a minute, if the lines are parallel, Euclid gives us these full relationships. Consecutive interior angles are supplementary. Everything else is congruent, alternate interior, exterior, and corresponding. And we looked at all of those different stories. We did a couple proofs, completing this proof, and understanding how we can jump from one parallel line system to the next. We played with a bunch of angle relationships. This is when we started talking about flow proofs. And we said, okay, a traditional 2-column proof for this wasn't so hard to figure out. And then we played with looking at it as a paragraph proof. Now, I'm recording this, and I'll post it. So if you don't have these notes filled in, you can log on, pause the video, and make sure you can catch up to what it is that you need for each of these kinds of proofs. Having the same proof 3 different ways, your note sheet looks like this, allows you to compare. The paragraph proof is my favorite. It's a little bit more casual, conversational. Kids end up liking the 2-column. Every now and then I get a kid that loves the flow proof. Okay, our next bits of notes was when we introduced the idea of the converse. If those cool relationships are true, then the lines are parallel. And our same cool relationships, so we got more of a chance to review those vocabulary words. On the back of these notes, we had a couple proofs and solving situations. Any questions about the stuff on the back of these notes that we didn't get to or you want to go over? All right, here's your homework. I asked you to do this sheet, please. Will you compare your answers with your group mates while I walk around and check in with you? Take down homework 3-2 and check. All right, let's quickly go over your homework answers. So what value of x makes A parallel to B? X is equal to 70. Here's the really hard part. When it comes to your justification, depending on where your brain went, you could come up with like 4 different answers. So for me, x is here as far as this red line, and 2x minus 30 is here where the blue is. I don't have a relationship between those 2 angles. They're not corresponding, they're not alternate interior, they're not consecutive interior. I'm going to need to do 2 things to find out their relationship. And depending on what first thing you did, your second thing is going to be different. Listen up to me, please, and pay attention. If I chose to go green with a linear pair to x, then I would need to do corresponding to 2x minus 30. If I chose to go purple and go vertical angle, then purple and blue have to be consecutive same side interior angles, and they'd be supplementary. If I chose to go red, then that means that these are alternating exterior angles, and these two are a linear pair. So depending on what I saw first in my mind, my second answer, so your justification could be completely different from the person sitting next to you, but you could still get it right. It depends on how you look at it. When I look at number 2, A is parallel to B because of these corresponding angles. C is parallel to E because of these alternating, no, C is parallel to E because of these alternating interior angles. Somebody last class wanted C and D to be parallel, and they are not.
What? Why not?
C and D are not parallel. See, you have the same question they did. Here's line C, and here's line D. What angle relationship do you see that you think makes them parallel? This angle here and this angle here have no relationship. We don't know a relationship of them. This angle here and this angle here do not share a transversal. So nothing there makes me parallel. A and B are parallel, C and E are parallel. All right, so the justification for this one, alternate interior angles. They're parallel because of the converse. Hey, number 2, those opposite sides of the picture frame, there's a parallel, center line of soccer field, perpendicular. I hope those airplanes are askew or else they're crashing. When you close your computer screen, you've got parallel planes. And the line where your computer screen and keyboard meet, and whatever door frame is in the room, those are going to be skewed. Next up, and this is what I need you to understand. If the lines are parallel, and that's what we're given in each of these situations, in every single one of these situations, we are given parallel lines. We are given parallel lines. Given parallel lines. So everything is either going to be a skinny or a fat. Once those lines are parallel, you have 2 choices. Is it acute or obtuse? And if it helps you draw things more exaggerated to tell the difference, go ahead and do that. For angles 1 and 2. Any questions on 8 through 13 you want to talk about? Okie dokie. 14 says, I want A and B to be parallel, but I don't know if they're parallel yet. What value of X is going to make them parallel? So we're back to the converse. Give me congruent angles or give me supplementary relationships so then I know the angles are parallel. In this first one, if X has a value of 12, then the lines will be parallel by the converse of the alternate interior angles theorem. Letter B says if X has a value of 54, then by vertical angles and corresponding angles converse or alternating exterior angles. Whichever one makes sense to you, those angles will be parallel, or those lines will be parallel. Letter C, if X has a value of 37, then I'll have a supplementary relationship. And by consecutive interior angles, they'll be parallel. So this one's kind of cool. Sketch a diagram, write a paragraph, prove. If a transversal intersects 2 parallel lines, so I already have my lines parallel. I know that that's true. I want you to prove that the bisectors of the two corresponding angles are also going to be parallel. So what's interesting here is I have my corresponding angles congruent because the lines are parallel. If two lines are parallel, then corresponding angles are congruent. By definition, a bisector divides that angle measure evenly into two. So those values of each of the bisected angles are going to be equal. So this angle measurement here is going to be the same as this one. Those bisectors create parallel lines, and then those corresponding angles are congruent. So if those corresponding angles are congruent, then the lines are bisected. Then the lines are parallel. Sound okay? All right. Your homework tonight is going to center around 3 new but very obvious theorems that just require reading. And I'll bring these papers around to you while you're taking your quiz. The two lines are parallel to the same line, they're parallel to each other. Take 3 pens, 3 colored pencils out of the basket, line them up in a row with parallel lines, and you'll see what I mean. If 2 lines are parallel to the same line, they're parallel to each other. Take your 3 pens right now and line them up. Does it make sense that if 2 are parallel, the third one is too? Are you okay with that one? Okay. Check out this one. Ready? Hey, Sumner. Thanks. Here's our next one. In a plane, if 2 lines are perpendicular to the same line, they're parallel to each other. Would you please, with your pens and pencils in your group, go ahead and show me a perpendicular set of lines? Give me a third line that's parallel to one of them. Your little diagram fits exactly what we're talking about here. In a plane, if 2 lines are perpendicular to the same line, then these lines are going to be parallel. This next one just talks about it in a different order. If a line is perpendicular to one of 2 parallel lines, then it's that's perpendicular to the other one. I'll bring these notes and tonight's homework around to you while you're taking the quiz. Any questions? Yeah. The converse of which one? If any of these congruent or supplementary relationships exist, then the lines are parallel. So all your same relationships, alternate interior, alternate exterior,